Okay, in this video, Hermson teaches how to graph rational functions. In this function here, you got y equals the square root of x, okay? Now, it's just a square root. I'm not going to be putting that 2 in there. You got to know it's a 2, so just put a little 2 right there. Now, pretty much the only way to do this is with a table, okay? Now, you're going to set up the table much differently than what you've done in the past. In a square root function, your independent variable x is inside of a square root. So what we want to do is put to make this easy as possible, we're going to put numbers in for x that are perfect squares, okay? So you're going to put 0 right there. I want you to put 0 in the middle of the table. Then I want you to just pick your first 3 perfect squares, okay? You are going to pick 1. I want that. And then you go 4, 9. Now I could have you go to 16, to 25, to 36, to 49. I could do that all the way. Now you're like, well, why did you put the 0 there? Well, the question is, can you put negatives in square roots? No, you can't. So what you do is you make kind of a block off. That means negatives are not going to be part of this domain right here. Then you just put the numbers in. What's square root of 0? 0. Do that number first. What's square root of 1? 1. What's square root of 4? 2. What's square root of 9 equal to? 3. Now, plot them. I want you plotting this point first, and I want you to label that in coordinate form. 0, 0. Then 1, 1. By the way, your x goes to 9, but I think you can hit that pretty easily. 1, 2, 3, 4, 5, 6, 7, 8. Yep, you can. So you don't have to number the x off by 2s. Everything, you can go by 1s here and 1s here. Okay, so 9, 3. So 1, 1. Sorry, 1, 1. 4, 2. 1, 2, 3, 4, 1, 2. Then 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Now connect the points in the order that they were plotted. Right there, right there, right there. Now we keep going this way with an arrow, but not this way, okay? That's a dead end because you can't put negatives in the square root. Now you do need to label your domain and range. That's why I had you label this point, okay? X, Y. So here's how you label your domain. You put X, you put Y. Now X is 0 and Y is 0. Now as far as your domain, your greater than and less than signs, here's how you find the sign with the domain. Make a vertical line through that point. Just make a straight vertical line. Make it dashed. Are all points to the right or left of that line? They're all to the right. Okay? So it's greater than or equal. If it was they were all on this side to the left, I'd use less than or equal to. Now your range, you make a horizontal line through that point. Okay? So to find your domain, you make a vertical line through that point right there, and the range, you make a horizontal line through the point. Now, are all points above that line or below it? That line, that horizontal line through the end point. They're all above it, okay? So that's greater than or equal to as well. Okay. So x can't be anything greater than or equal to 0. Y can't be x is everything greater than or equal to 0. Y is everything greater than or equal to 0. Okay, now cubed root. Y equals the cubed root of x. Still a radical function. It's just a cubed root. Now, cubed roots are different than square roots, okay? You put a 0, but now you're going to go with cubed roots. I know I don't have 1 on the list, but I want you to put it. So 1, 8, 27. Now, cubed roots open up your negative side. So negative 1, negative 8, negative 27. Okay, so what's the cubed root? Let's do 0 first. Cubed root is 0, 0. What's a cubed root of 1? 1. What's a cubed root of 8? It's 2. What's a cubed root of 27? What times what times what's 27? It's 3. Okay. Now, if you put negative 1 in a cubed root, you're going to get negative 1, okay? Negative 8 is going to give you negative 2. Negative 27 gives you negative 3 because cube root of negative 27, because now you have an odd number of negative factors, so that can equal the negative. Okay, plot them. Plot your 1 in the middle first, 0, 0. Then 1, 1. Okay, we have a little problem. The x's we're going to need to number out by 5s because we have to get all the way to 27. Okay, so we'll have every one in the x be worth 5s. Then 1, 1. Okay, so forward 1 would be here. Now the y I'm still going to make worth 1s. Okay, so forward 1, up 1. 8, 2, forward 8, up 2. Forward 27, up 3, 5, 10, 15, 20, 25, 27, 1, 2, 3. Okay. Now you also have your net. Now make that arrow on that end. Now you have to do the negatives as well. So negative 1, 1. Remember, this is by 1s, but remember, this one's by 5s. Okay, so negative 1 would be here. That one's wrong. Negative 1, and then negative 1. We'll have that one be worth 1s. Okay, negative 8, negative 2, so negative 8, remember you're going by 5, so negative 8 would be about there. Negative 5, negative 10, so negative 8 there. And then negative 2, you're still going by 1s there. Okay, so you connect them. Negative 27, negative 3, so on x, negative 27, 5, 10, 15, 20, 25, 27, and then the y is 1, 2, 3. And the arrow goes that way. Well, when I have arrows in both directions, that's going to make for an easy graph. The domain is called UR, unrestricted, and the range is unrestricted as well. Cubic functions, the domain range isn't a problem. It's a square root. Okay, now y equals the square root of x plus 1, so it's a square root, okay? Now you're going to set up your table, parent function of a square root. That's when you go 0 and only perfect squares. 1, 4, 9. Now you could go up to 16 to 25 and all that. Remember, you block it off because you can't have negatives in cube roots and square roots, pardon me, okay? But it is a square root. Now you need to translate the function, and you are going to use your HAK principles. So here's what I do. I look for an h. H would be inside the radical, but plus 1 is outside the radical, so there is no h, okay? H's, if you have them, have the opposite effect to your x's. By the way, you know the square root of 9 is 3, 2, 1, 0. You just square root those numbers. So you fill that out right away. I should have been doing that before I talked about this. Okay, so the h, you don't have any h's, so the x would remain the same. Now a would be a multiplier in front of the square root. We don't have that. If we do, it has the same effect to the y. Now k are numbers that are added and subtracted outside the square root, and we have a k value, okay? Those k values have the same effect to the y column. So plus 1 would have that same effect to all your y amounts. So 3 plus 1 is 4, 2 plus 1 is 3, 1 plus 1 is 1, 0 plus 1 is 1. Or 1 plus 1 is 2, my bad. Now graph them. 0, 1 needs to be graphed first. So on x you have to get to 9, which you can make by 1s. Y you have to get to 4, you can make that by 1s. Okay, so 0, 1. Please label that point. That's important for the domain and range. 1, 2. Forward 1, up 2. Connect. 4, 3. Forward 4, up 3. Connect. 9, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 1, 2, 3, 4. Connect. And you can keep going that way. Now, that point right there is your domain, 0, 1, x 0, y 1. So the domain x 0, y 1. Now, make a straight vertical line through that point. All points are to the right, okay? Since all points are to the right, it's greater than or equal to 0, okay? Now make a horizontal line through that point. all the points are above that little horizontal line through that end point. So above would be greater than or equal to 1, okay? And that's your domain and range. Okay, next one. Y equals the square root of x minus 2. Okay, so it's a square root, so I'm setting up the same parent function. 0, 1, 4, 9, square root those numbers. 3, 4, be 2, 1, 0. Okay, there's the square root beginning, there's where it ends. Do you have any h's in there with the x? No, you don't. So the x's will remain the same. A, do you have an a out front of the square root? You don't. K, do you have a number added or subtracted? You do. K values have the same effect to the y, so you subtract 2 from all of those y values. So 1, 0, negative 1, negative 2. Because you see, if I put 9 in the square root, the square root of 9 is 3, but when you take away 2 from the 3 after that, it's at 1. Square root of 4 is 2. When you take away 2, you end up at 0. Square root of 1 is 1. Take away 1, you're at negative 1. Square root of 0 is 0. Now, you can have negative outputs after you do your k, but so forth, okay? Okay, x's go by 1s. Y's, those can go by 1s as well. So 0, negative 2. You graph that point because that's your x, that's your y. That becomes very important in the domain range. That's what drives the domain and range. 1, negative 1, forward 1, down 1. 4, 0. 1, 2, 3, 4. Connect them as you make them. Then 9, 1. 9's all the way here, 1, and that graph would keep going if it were bigger. Okay, circle that point. That's your domain. So domain x, y, 0, negative 2. Okay, make a line that runs through that point, vertical. Are all points to the right or the left? They're all to the right. So x is greater than or equal to 0. Now make a horizontal line through it, okay? Are all points above or below that line that I just made? They're above. So it's greater than or equal to negative 2. Okay, next problem. Y equals the square root of x minus 3. Y equals the square root of x minus 3, all in the square root. So it's a square root, so set up your parent function of square roots. Remember, square roots don't include negatives. 0, 4, 9. The square root of 9 is 3. The square root of 4 is 2. The square root of 1 is 1, then 0. Now, do you have an h value? Parenthesize the, oh, you do, don't you? That's an h right there, if it's inside the square root. Those have an opposite effect to the x values. So the opposite of minus 3 would be plus 3 to all of my x values. So 9 plus 3 is 12, 4 plus 3 is 7, 1 plus 3 is 4, 0 plus 3 is 3. Now, do you have an a value in front? No, you don't. Do you have a k value? Do you have something added or subtracted outside of the radical? No, you don't. So the y stays the same. But the x's you're going to need to number off by 2s so that you can make it to 12, and the y by 1s. So 12, 3. 2, 4, 6, 8, 10, 12, 1, 2, 3. Or no, do your 3, 0 first. I'm so sorry. Okay, 3. 2, 3. And label that 3, 0. X3, Y0. Now 4, 1. Remember, you're going by 2's here, so 2, 4, 1. Okay, 7, 2. Remember, you're going by 2's here. 2, 4, 6, 7, and then 1, 2. Okay, and then the 12, 3 is right there. So 2, 4, 6, 8, 10, 12, 1, 2, 3. Okay, domain and range. So domain x, range y. X has a 3 value. The y has a 0. Okay, make the horizontal line first. Are all points right or left? They're to the right, so greater than or equal to 3. Now make your horizontal line. Are all points above or below that? They're all above, so greater than or equal to 0. Okay, next one, y equals square root of x plus 6. Okay, y equals square root of x plus 6. So it's a square root. So I go 0, 1, 4, 9, because those are the numbers that are very easy to square root. 0, and also don't put the 2 here, because otherwise you'll think that's an a value. Just put a square root, or a 2 or something right there. Okay, so square root of 1 is 1, square root of 4 is 2. What times itself is 9? That'd be 3. Now, you got to make the transformation of your table. So h, here's how you find where your h is. You make a parentheses in there. So that's, you have a number in there, that's an h value. H's have the opposite effect to the x. So plus 6, what's the opposite? Minus 6. So 9 minus 6 is 3, 4 minus 6 is going to be negative 2, 1 minus 6 is negative 5, 0 minus 6 is negative 6. Okay? Now, do you have any a values? You don't. Okay? Do you have any k values? Do you have anything being added outside the radical? No, you don't. Okay? So you can make it by ones on both the axis. So 3, so do your negative 6, 0 first. So 1, 2, 3, 4, 5, 6. Negative 6, comma 0. That's x, that's y. Okay? Then negative 5, 1. 1, 2, 3, 4, 5, up 1. Okay? Negative 2, 2. Back 2, up 2. And then negative, and then 3, negative 3. So 1, 2, 3. Or 3, 3, my bad. 1, 2, 3. So 1, 2, 3, 1, 2, 3. Okay, and that keeps on going. Now your domain. X, the value at the domain is negative 6. And then Y, it's 0, but you got to put inequality. Okay, make that vertical line. All points run to the right, so greater than or equal to negative 6. Eats the x. If it goes to the left, it eats a number. Okay, then horizontal line, all points are above, so greater than or equal to 0. Okay, now we're going to do cubed roots. These are there's more points to graph, but the domain and ranges are easy because they're unrestricted, because you can put negatives in the square root. Need a bigger table though. So now you're doing cubed roots, okay? So we want to be using perfect cubes. So that doesn't go 1, 4, 9, that goes 1, 8, 27. And you could do 64, but you also open up the negative side, okay? So the cube root of 27 is 3. Cube root of 8 is 2. They say it right there. Cube root of 1 is 1. Cube root of 0 is 0. And then these would just be negative 1, negative 2. Reason why those are opened up, because if you take a negative 3, you can get negative 27 out of that. Now you can't get it with a square root, but you can with a cube root. Okay. Alright, so what do we got here? To see if we have h's, you parenthesize the inside. There's nothing there but x, so there is no h. We leave the x's put. A's have the same, there is no a, so forget that. That 3 is not an a, that's a cubed root. An a would be right there. And then you have any adding or subtracting done outside the radical? You do. So that's a k. K values take the same effect to y, so you minus 4 from all of these values. 3 minus 4 is negative 1. 2 minus 4 is negative 2. Then it goes negative 3, negative 4, negative 5, negative 6, negative 7. Okay? Alright, so we got to get to 27 on x, so we're going to have to go by 5s. We have to get to negative 7 on y, which we can do by 1s. So 27, negative 1. So 5, 10, 15, 20, 25, 27, and then negative 1 would be down here. Or, sorry, do the 0 first, I'm sorry. Okay, 0, negative 4. So 0's in the middle, negative 1, 2, 3, 4. Now label that, just like you would. Then 1, 3, remember 1's here, because you're going by 5s that way, then negative 1, 2, 3. Okay, 8, negative 2, so 5, and then 8's right there, then negative 2's right here. Okay, and then your 27, negative 1, 5, 10, 15, 20, 25, 27's right there. And then there you go. Okay, that way. Now you also open up the negative side, so negative 1, remember by 5's, then 1, 2, 3, 4, 5. Okay, negative 8, negative 6, so 5, negative 8, 1, 2, 3, 4, 5, 6. It's easy to forget that you're going by 5, so keep that in mind. Negative 27, negative 7, 5, 10, 15, 20, 25, 27, 1, 2, 3, 4, 5, 6, 7. Okay. Now the domain and range are unrestricted because there's not that little endpoint because it goes in each direction. So you are. Okay, this time y equals the cubed root, and the cubed root covers the expression x plus 5. So again, make your parent function of cubed roots. So 27, 8, 1, 0, negative 1, negative 8, negative 27. That's how to do a cubed root. So cubed root of 27 is 3, 2, 1, 0, negative 1, negative 2, negative 3. Now we have to transform the function. Now, first look for h values, and we have one. That is an h. How does an h affect the graph? It has the opposite effect to the x. So you minus 5 from your x's. 22, 3, negative 4, negative 5, negative 6, negative 13, and negative 32. Okay. Got any A's? No. That again, that 3's of the radical's degree. It's not a multiplier to the radical. Okay. Is there any K's outside being added or subtracted? No. So the y remains unaffected. But we still do need to go by 5's on y, 1's on x's. Or 5's on x's, 1's on y. Okay, so plot that middle one first. Negative 5, 0, 1, 2, 3, 4, 5. And then negative 5, comma 0. Then negative 4, 1. Whoops, my bad. We're going by 5's, aren't we? So negative 5 would just be back 1. See how easy that is to mess up? I just did it there. Okay, negative 4, 1. 3, 2. So forward 3 would be this way. Then I'm still counting by 1's there. And then 22, 3. 5, 10, 15, 20, 22, 1, 2, and 3. Now you got negatives as well, okay? So negative 6, negative 1. Negative 6 is there, negative 1, negative 13, negative 5, negative 10, negative 13, and then 1, 2. Negative 32, negative 3, 5, 10, 15, 20, 25, 30, 32, 1, 2, and 3. Okay, that's how a cubed root function looks. Okay, domain unrestricted, range unrestricted. Okay, now the last group of problems. Now this is a square root. So we go back to our square root function. 0, block, they can't have negatives, and it goes 1, 4, 9. So find the square root of these numbers. The square root of 9 is 3. Again, if you want to put a square root there, it's all you do. Square root of 4 is 2, 1, 0. Now, look for h values. That's an h. Those have the opposite effect to x. Okay? So, minus 1 takes you to 8, 3, 0, negative 1. You're just minusing 1 from all of them. Now, we have an a this time. A. You look at that first. Those have the same effect to the y. So if it's times 3, we times the y by 3. Now, before you times them by 3, see if you have a k, because those also affect the y. But you do the a first, okay? A comes before k, because times comes before adding, subtracting. There ain't a k value, okay? So it's just times 3. So that's 9, 6, 3, and 0. So I think we're good to go by 1's, but negative 1, 0 has to be plotted first. X, Y, okay? 0, 3, 1, 2, 3, 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. And then 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And an arrow that way. Okay, so your domain, it's based off that. Now you have to actually think on the domain because they don't go both ways. Okay, so -1 is your x, 0 is your y. Make the vertical line first. All points are to the right because x is right, left. All points to the right mean greater than or equal. And all points are above that point on the y-axis, above, greater than or equal to 0. Okay. Next one. 2, now we have a cubed root. Okay, it's a cubed root. So now we're making our cube list. It's more points, but the domain and range isn't near as confusing because we know right away those are going to be URs because the arrows will expand both ways. Okay, it's 2 cubed root x minus 6, and that's all under the cubed root. And then -9. And then outside the cubed root. The -9 is outside. The -6 is inside. That's important. Okay. Okay, cubed root. 0, 1, 8, 27. We also have the negatives. Now you just find what the cubed root of those numbers are. It's that simple. Okay. Let's look on your sheet. That's 3, 2, 1, 0. Negatives also have them. They're just negatives. Okay, parenthesize the inside. You have an H right there. H is an opposite effect to the X. So you're going to need to plus 6 to all your X's. So 27 plus 6 is 33. 8 plus 6 is 14. 7, 6. -1 plus 6 is 5. -8 plus 6 is -2. -27 plus 6 is -21. So the X's are set. H is the only thing that affects the X. But there's two things that affect the Y. A, you look first. Do you have an A? Yeah, you do. So you times 2 first, but you've also got a K. So you do the A first, same effect to Y, times 2. The K has the same effect to Y as well, but you got to do the A, the times 2, before the -9. Please excuse my dear Aunt Sally, multiply comes before adding and subtracting. Okay? So 3 times 2 minus 9, -3. 2 times 2 is 4, minus 9 is -5. 1 times 2 is 2, minus 9 is -7. 0 times 2 is 0, minus 9 is -9. And then it's going to go in that pattern, okay? Yeah, the Y's do form a pattern. The X's not so much. Okay, you're going to have to go by 5s on X, and you're going to have to go by 2s on Y. So, graph that middle point, 6, -9. So 5, 6, and then 2, 4, 6, 8, and then -9. Okay, then you spike up 7, -7. So 5 and then 7, then 2, 4, 6, 7. Okay. 14, -5. 5, 10, 14, and then -5 right there because you're going by, or my bad, it's 2. My bad, so that's the wrong point. 5, 10, 14, okay, and then -2, -4, -5. Okay, 33, -3, 5, 10, 15, 20, 25, 30, and then 33, okay. Then you have to go to -3, so -2, -3. Arrow goes that way. Okay, then 5, -11. So remember, you're going by 5, so 5, -2, 4, 6, 8, 10, 11. Okay. -2, -13. So remember, by 5s, -2 would be here. Then by 2s, -2, -4, -6, -8, -10, -12, and -13. Okay. -21, -15. So 5, 10, 15, 20, and then 21. and then negative 15, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 15. Okay, and the nice thing, the domain and the range are both unrestricted. Okay, next one, y equals the cubed root of x plus 3 minus 1. So it's a cubed root function, so you make your cube list. So 0, 1, 8, 27, because those are your cube numbers that can be cube rooted very quickly. Negative 1, negative 8, negative 27. Now you just cube root the numbers to start with. Don't worry about anything else. Just pretend that's all you have. The cube root of 27 is 3. The cube root of 8 is 2. 1, 0, and then they just become negatives. Okay, that's an H. Those have the opposite effect to the X. So opposite of a plus 3 is a minus 3. Now, do you have an A? That is not an A. That's a cubed root. There's no factor in front, so no A. But you have a K. What does a K do? It has the same effect to the Y. So 27 minus 3 is 24. 8 minus 3 is 5. 1 minus 3 is negative 2. 0 minus 3 is negative 3. Negative 1 minus 3 is going to be negative 4, negative 11, and negative 30. Well, we're probably going to have to go by 5s to make that. Now on the y, we subtract 1. Okay, 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Negative 1, negative 2, negative 3, negative 4. You can go by 1s on the y. So negative 3, negative 1 is your middle. So you're going by 5, so negative 3 is here, and then negative 1. Okay, that's your x, that's your y. Okay, then we'll go negative 2, 0. So negative 2 is there, keep in mind, we're going by 5s. Okay. 5, 1, so you go 5 and then 1. And then 24, 2. 5, 10, 15, 20, 24, and then 1, 2. Okay, now your other ones, the negatives. Negative 4, negative 2. So negative 4 is right there, and then negative 2 right there. It's not going to be a work of art. Okay, negative 11, negative 3. So negative 5, negative 10, negative 11, down 1, 2, 3. Okay, and then negative 30, negative 4. So 5, 10, 15, 20, 25, 30, and down 1, 2, 3, 4. Okay, there you have it. Domain and range are unrestricted. Okay, and the last one, you got a square root. Okay, it's a square root. Don't put. You can put the 2 in there. That's fine, but just know that's not your A value. Now there ain't going to be as many points here, but okay, square root function. That would be a 1. 4 times 2 times 2 is 4. 3 times 3 is 9. Now what are those square roots? What number times self is 1? What number times self is 4? 3. Now you make the transformation. Let's talk about the x. Parenthesize the inside, that's an h. Those oppositely affect the x. So minus 2. So that's 7, 2, negative 1, negative 2. Well, we'll be able to make that by 1s. Okay. Then, do you have a multiplying number in the front? You do, an a. You also have a number added, that's a k. The a's and the k's have the same effect to the y, but the a has to be done first. Times negative 5 followed by a minus 3. So 3 times negative 5 minus 3, negative 18. Okay. Then you take 2 times negative 5 minus 3, negative 13. 1 times negative 5 minus 3, negative 8. 0 times negative 5, well that's 0, minus 3 would be negative 3. Okay, you're going to have to probably go by 2's to hit the y. So you graph your negative 2, negative 3 first. So back 2, and you're going by 2's on the up-down part, so 2, 3. So that's x, that's y. Very important to have that label. Negative 1, negative 8. So back 1, and then negative 8, 2, 4, 6, 8. Okay, then 2, negative 13. So forward 2, then count by 2s. 2, 4, 6, 8, 10, 12, 13. Tell you what, in this video I told you the wrong 2s won't work, but we're just going to say heck with that last point, make an arrow. Now that point's the key, negative 2, negative 3, because it can't expand beyond that point going this way. So x is negative 2, y is negative 3. Now make a horizontal straight vertical line. All points are to the right again, so greater than or equal. But when I make the horizontal line, all points are now below that line. So now it won't be, the y will not be greater than, it will be less than or equal to negative 3, because now they're all below it.